Welcome to College Algebra, MAT 150. Today we're going to start on the review of stuff we need to do for week one, and we're going to start with inequalities. So a number is less than another number if it is more negative than the other. And when we're dealing with inequalities, we have two types: strict inequalities and inclusive inequalities. Strict inequalities do not have the equal sign under them, and you have to be strictly bigger than the other or not for it to be a true statement. Inclusive inequalities can still be true if they are the same number, though. So otherwise, they are similar to their strict inequality brethren. So let's look at this first example. Determine which of the following mathematical statements are true. So we're just saying, hey, is this true or not? That's the only answer that we're looking for. So 3 is less than 7. That's true because on the number line, again, number lines go from negative to positive. 3 is somewhere right here, and you have to go 4, 5, 6, 7 to get to the next one. So yes, is it more negative? Yes, then 7, so this is true. What about negative 3 greater than 7? Well, we have negative 3 here, again, negative to positive, we'd have to go 1, 2, so negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7 to get to 7. So negative 3 is less than negative 7. So this is false. So we're just reading in this case from left to right. And this one, and going back to this one, the equal sign doesn't matter. The fact that 3 is in fact less than 7, we don't need the other part of being equal. This is one that messes with people. Is negative 3 less than negative 7? Well, which one is more negative? Well, as it turns out, when you start from 0, again, just like we were counting here, it goes negative 1, negative 2, negative 3. Well, negative 7 is all the way over here. So negative 6, negative 5, negative 4, negative 3 would be here. So negative 7 is, in fact, less than negative 3, not the other way around. So this is false. What about negative 3 being greater than or equal to negative 3? Well, it's not greater than, but they are the same numbers. So the fact that we have the equal sign makes this true. And if we had negative 3 greater than negative 3, that would be false, for example. So with the greater than or equal to versus just the strictly greater than. All right, so again, stuff that maybe you haven't seen for a while, but again, this is just a review. This week is only for review. So let's look at what a solution is. A solution in mathematics is for any mathematical statement, is something that makes the statement true. Okay, so if we look at this example below, x greater than negative 5. Okay, so anything that makes this statement true is a solution. Okay, so which of x equals 3, 10, and negative 10 are solutions? So x equals 3, well, is 3 greater than negative 5? Well, 3 is more on the right of the number line or more positive than negative 5, so yes, it's true. So x equals 3 is a solution. Okay. What about x equals 10? Again, 10 is greater than negative 5. This is true. So again, since x equals 10 makes this a statement, it is also a solution. Okay. But x equals negative 10. Negative 10 is in fact not greater than negative 5. It's less than because it's more negative. It's further on the left of the number line. So this is not true. So x equals negative 10 is not a solution. So how many solutions are there? Well, there are infinitely many. It's for an inequality at least. So something like an inequality has infinitely many solutions, and something that we're going to talk about in the next lecture, also for this week, is going to be how do we talk about all these solutions? We use a thing called interval notation. I'll see you in the next